Imagine a customer places an order on Amazon. The order must update inventory, process payment, send notifications, and trigger analytics. But how should these systems communicate? Should one service call another directly? Should messages be queued? Or should events be published? These are the decisions architects make every day. In this video, we'll learn REST APIs, message queues, and event-driven architecture in the simplest possible way. Let's use a simple shopping application. A customer clicks place order. Now several things must happen. Payment must be processed. Inventory must be updated. Notifications must be sent. Analytics must record the purchase. The question is not what needs to happen. The question is how these systems should communicate. That's where architects evaluate different integration patterns. A REST API is the simplest communication method. One service directly calls another service and waits for a response. Think of it like making a phone call. You ask a question and wait for an answer. Order service calls payment service, waits for confirmation, and then continues processing. REST APIs are simple, easy to understand, and perfect when an immediate response is required. REST APIs are great for real-time interactions. User login, payment validation, profile updates, and product searches commonly use REST APIs. However, there is a challenge. If the target service becomes unavailable, the request may fail. Services become tightly connected. As systems grow, architects begin looking for more resilient communication methods. A message queue works differently. Instead of calling another service directly, a service places a message into a queue. The receiving service processes the message later. Think of it like leaving a package in a mailbox. You don't wait for the recipient. This approach improves reliability because messages remain in the queue even if the receiving service is temporarily unavailable. Imagine a flash sale where thousands of orders arrive within seconds. Direct service calls could overwhelm downstream systems. A queue absorbs the spike and processes messages gradually. This protects services from overload. Architects often use queues for emails, notifications, report generation, image processing, and background tasks that do not require an immediate response. Event-driven architecture takes communication one step further. Instead of directly telling another service what to do, a service publishes an event. For example, order placed. Any interested service can react to that event. Payment service processes payment. Inventory service updates stock. Notification service sends an email. The publisher doesn't need to know who is listening. Event-driven systems are highly scalable and flexible. New services can subscribe to existing events without changing the original application. For example, if the business wants a recommendation service tomorrow, it can simply subscribe to order-placed events. Existing services remain unchanged. This loose coupling is one reason large enterprises prefer event-driven architectures. Architects don't ask which technology is better. They ask what problem needs solving. Need an immediate response? Use REST APIs. Need guaranteed delivery and reliability? Use a message queue. Need multiple systems reacting independently? Use event-driven architecture. The correct choice depends entirely on the business requirement. Let's summarize. REST APIs provide direct communication and immediate responses. Message queues improve reliability and handle traffic spikes. Event-driven architecture enables scalable, loosely coupled systems. Great architects understand all three patterns and know when to use each one. In our next video, we'll go deeper into event-driven architecture and explore how technologies like Kafka make modern systems scale to millions of users. Don't forget to like, subscribe, and join the TechMechanic.